we're going to talk about triangle proportionality theorem in this one. So it's really pretty basic, and all it's saying is that if line DE is parallel to AC, then it divides the segments into proportional parts. So because DE is parallel to AC, I can now say so let's write this down. If DE is parallel to AC, then BD is proportional to DA, and BE is proportional to EC. Okay, so BD is proportional to DA, BE is proportional to EC. I can also take the converse of that and say that if BD over DA is proportional to BE over EC, then I have DE is parallel to AC. So of course I can reverse that with the theorem. Let's take a look how to solve these algebraically. I'm just going to do the odd numbers for you. So if you look at number 1, now I want you to notice about 1, 3, and 5, well, all of these actually. I know that these are parallel. Because they're parallel, that's the reason I can make these statements. So because these lines are parallel, I can say that x is proportional to 15 and 14 is proportional to 12. Notice I'm taking the bottom chunk, that's my x, and then the top piece is 15. So on the other side, I have to be, the same. I'm taking 14 as my bottom part and then 12 as my top part here. So you've got to make that consistent. And of course, in this case, now we have a proportion so we can cross multiply. What I like to do is I like to simplify my fraction first. So over here, I'm going to go ahead and make this 7 and make this 6 because it makes it easier when I cross multiply. So 6 times x is 6x. 15 times 7 is 113. Sorry, I think that's 113. Golly. 35, 7, no, it's 105. 105. I'm way messed up. 70 and 35 is 105. And then divide both sides by 6. Wow, that took me forever. So 6 goes into 10 one time. With 4 left over, 6 goes into 45. 7 times. And then my remainder is going to be 17.5. Okay, so that took forever and was certainly ugly, but that's how I set my proportion up. Now, watch closely what I do down here on number 3. I'm setting x proportional to 36, the small piece. So now I have to do the small piece here. Well, if the whole piece is 55 and this piece is 45, 10 is going to be my small piece here. So I'm going to set it equal to 10 over 45. Real good it did me reducing last time. So here I get 45x is equal to 360. Divide both sides by 45, and x is going to equal 8. So that's my answer for number 3. Go ahead and jump down to number 5. You guys can go ahead and get started, and let's see what we get as you set yours up. Okay, so the setup here is I'm going to set 30 proportional to x plus 7, and then I'm going to do the same. 25 is proportional to 15. Okay? So now here I am going to reduce, and I get 5/3. So when I cross multiply, I get 5 times x plus 7 equals 90. 3 times 30. Of course, I distribute and then subtract 35 on both sides, and I get 75. No, I don't. What is wrong? 55. Golly. 55, and then divide both sides by 5, and x is equal to 11. Now, keep in mind, you got to make sure it's asking for x, not the length of a side. Okay, now jump down to number 7, and my directions have changed. Now my directions are saying, okay, R, M, N, and J, L parallel to each other. So now we're looking at the converse of that proportionality statement. So is 11 over 15.4 equal to 10 over 14? So this is where I can find that aspect ratio. Or I can cross multiply and I get 154 equal to 154. So I can look there and I know they're proportional. So yes, they are parallel to each other. If these numbers did not come out equal, then of course they would not be proportional. So we can take the aspect ratio that we talked about in class. You can cross multiply, however you want to do that. Now, what happens when it doesn't form a triangle per se, but we still have parallel lines? Well, that's okay too, because if 3 or more parallel lines intersect 2 transversals, then they make the transversals proportional to each other. So, if line AB is parallel to line CD, which is parallel to line EF, then I can say AC is proportional to CE and BD is proportional to DF. So it's almost the same, except, instead of making a triangle, we here have cutting through 2 transversals. So it's going to look the same. So 45 over 18, because these are parallel, I can say 45 over 18 and set it equal to 52 over x. And here, when you cross multiply, you have 45x equals 936. And when we divide both sides by 45, x then equals 20.8. Okay, let's do, actually I do want to finish 12 and 14 because they're a little different. So let me move that up. All right. So proportional parts, it's still the same. I need to find this information. How do you do it? Well, 32 minus 18. So when we subtract 32 minus 18, that's going to give me this length is 14. Now I can set up my proportional parts. I can say 27 is proportional to x and set that equal to 18, which is proportional to 14. Now when I cross multiply, I get 18x equals 27 times 14 is 378. And divide both sides by 18, and x then equals 21. Okay? All right, last one over here with the binomial. Same concept. I have these identified, so I can say 24 over 18 and set that equal to 3x plus 1 over 12, cutting it into proportional parts. I am going to reduce my fraction because it makes it easier now, so 4/3. Now when I cross multiply, I have 3 times 3x plus 1, and I set that equal to 4 times 12, which is 48. And here we distribute 9x plus 3 equals 48. Subtract 3 on both sides. 9x equals 45, and when I divide by 9, x is equal to 5. Okay, so that's triangle proportionality and proportional parts. Come see me if you are struggling.